look at is we're going to explore the relationships between corresponding parts of similar triangles. To get started, we're going to take a look at the warm-up together. We're going to construct a triangle and then create a median and angle bisector. And the two questions that we would want to look at are they the same line? And then what is the difference between a median and an angle bisector? So I've gone ahead and created a triangle in Desmos, and the angle bisector and median. The angle bisector is red, the median is green. So as you can see, the two lines, or the two segments, are not the same. The angle bisector is not the same line as the median. So are they the same line? We're going to say not necessarily. Okay. There might be instances when they could be the same line, but in this triangle they are not. So they are not necessarily the same line. And if you recall, the difference between a median and a angle bisector is a median is a line segment from midpoint of a side to the opposite angle. And an angle bisector is it's a line segment that bisects an angle and connects to the opposite side. Okay, so again, the angle bisector does not necessarily connect to the opposite side at the midpoint. So our question that we're going to look at is, are there more similar, or is there more to similar triangles than just proportional side lengths and congruent angles? So recall, we know that when you have similar triangles, the side lengths, the corresponding side lengths of the triangles are proportional, and all the angles are congruent to each other. So what we're going to take a look at is there a relationship in similar triangles between corresponding altitudes, corresponding medians, and corresponding angle bisectors? So we're going to do this on Desmos. You can follow along on Desmos if you would like, or you can just watch the video and listen to the discussion. So I have gone ahead on Desmos and I drew a triangle and I used a scale factor to construct a similar triangle of a different size. The first thing that we're going to look at is in step 2. We are going to construct a pair of corresponding altitudes. That means they go from corresponding angles to the opposite side, and we're going to compare their lengths. So if we come back over here, here's our two similar triangles. So what we know is that side AB is proportional to DE, and maybe we should go ahead and check that. So 2.12 and 4.19. This side is 3.99. This side is 7.9. So if we wanted to figure out the ratio, the relationship between those two sides, AB and DE, we would take 2.12 and divide it by 4.19. And what we see is that we have, if we go back to this, that the relationship between AB and DE is equal to 0.5. It's not exact, I'm rounding, but again, Desmos makes it tricky to be able to get precise numbers just because of it rounding. So AB and DE has a 0.5 scale factor. If you take 3.99 and divide it by 7.9, you get also with rounding you get 0.5. So we have BC or EF. So the relationship between BC and EF is 0.5. And if we were to take the relationship between AC and DE, DF, we would also come up with 0.5. So this is a similar these are similar triangles. And so what we're going to do now is we're going to take a look at their the altitudes that are drawn. And we're going to just see if is there a relationship between, is there a proportional relationship between those two segments. So if we look at the altitude, the blue lines or the blue segments inside the triangles here, if I label that altitude is 1.85, this altitude is 3.67. All right. So if we wanted to compare, and let's label that G and this H. So if we wanted to look at this, our altitude is BG, and the other altitude is EH. And the length of BG is 1.85, and the length of EH is 3.67. And if we take this ratio and see what it is after we divide these two numbers, we get 0.5 with 0.504 and then a bunch of numbers after that, but it rounds to 0.5. And so what you should notice there is that the scale factor for the altitudes is the same as the scale factors for the sides. So again, the question says, how does the comparison relate to the scale factor you used? So the scale factor of the altitudes is equal to the scale factor used for the sides. Okay. Now we're going to take a look at the medians and the angles, or angle bisector. Okay. So if we look at the median, I'm going to hide this number here. If the medians here are going to be the green, so we'll label that 2.24 and 4.43. Oops, unhide. So again, our medians, we'll label, so say this is I, and we'll label this J. So our medians are BI and EJ. And the ratio between those two is 2.24 to 4.43. And if we type that into our calculator, 2.24 divided by 4.43, we see that we get, again, approximately 0.5. Again, there's some rounding in there. And so how do their lengths compare? They are different by a scale factor of 0.5. And so what we can say is that the scale factor used for, or the scale factor of the medians is the same as or is equal to the scale factor used for the sides. Okay. And then we're going to look at one last thing, the angle bisectors. The angle bisectors are the red segments here. So we'll label that 1.94. And then we'll label this, or these points as well. So we have K and we have L. So what we have here is we have BK and EL. And those distances are 1.94 to 3.83. And if we come back to our notes, we have 1.94 divided by 3.83. You can probably guess, again, we get a scale factor of 0.5. All right. And so, again, what we have is the scale factor of in this case, the angle bisectors is equal to the scale factor used for the sides. So we should be able to make a conjecture now, And that conjecture is that if two triangles are similar, then the lengths of the corresponding altitudes, medians, and angle bisectors are proportional to the lengths of the corresponding sides. Now, what I want you to do is recall that when we first learned about angle bisectors, we may have thought that the angle bisector in a triangle also divided the opposite side into two equal parts. What we saw in our warm-up is that that is not necessarily the case. The angle bisector does not necessarily have to be a median as well. So what we're going to look at here, though, is we want to check out how does the angle bisector divide the opposite side, because there is a particular way that it does divide this opposite side, meaning it doesn't divide it in half necessarily, but what is the relationship between this smaller piece and this bigger piece? So when you have that angle bisector, what is this relationship right here? Are they proportional? Okay, so that's what we want to take a look at. So what we're going to do is we're going to jump back over to Desmos. We're going to do this investigation. I've already drawn the angle, and then I've already drawn rays, so that one is 6 centimeters and one is 12 centimeters, and then I've already constructed the angle bisector. So what we're going to do is we're going to measure the distance of CD and BD. So if we come over here, here's what it asks us to compare. And just so we see, if we wanted to check the relationship between AB and AC, we can see that 6 and 12, they are double. All right, 6 is, you have to double 6 in order to get 12. So what we're going to do is we want to compare the lengths of CD and I guess I haven't labeled this D, so we'll call this D. CD and BD. Okay, so we have 5.67 and 2.82. So on your notes, we'll see we have, so the length of CD is, so the length of CD is equal to 2.82, and the length of BD is equal to 5.67. Now it asks us to compare the ratios of CA to CA over BA and CD over BD. So if we look at CA over BA, that would be 6 over 12. So we have 6 over 12, that is equal to 1/2, and then we have 2.82, so that is equal to CA over BA. And then if we look at CD over BD, that is equal to 2.82 over 5.67, which when we divide that, we get, if we round up, we get 0.5. So what you see in 0.5 is equal to 1/2. So what we know, or what we notice, is that the side divided by the angle bisector has the same proportion or same ratio as the other two sides. And so if we did this for another triangle with a length of 10 and 15, we won't do that, but we would notice that the same thing occurs. So that leads us to being able to say that there's a relationship between the angle bisector and the opposite side in similar triangles. And what we say is that a bisector of an angle, or an angle bisector in a triangle, divides the opposite side into two segments whose lengths are in the same ratio as the lengths of the two sides forming the angle. Okay, so again, what that means in this picture is that you have your longer side right here. Let me make that just a little bit smaller. So we have our longer side here, and then we have our shorter side here, And what it's saying is when you have an angle bisector that divides up the third side, the longer side, the ratio of that longer piece, so BD, is going to be equal to is the same as CD. So again, what we're saying is when you have an angle bisector, it divides the third side into the same ratio as the longer side and the short side. So you have BA over AC equals BD over DC. So if we jump down here to this extra example, we would like to find out the measurement of X right here. So if we take a look at that, what we notice is that, first of all, we have an angle bisector. B is bisected. So BD is an angle bisector, and so what we know is that the ratio between AD and DC is going to be equal to the ratio of the other two sides. So what we have is we know AD over DC is equal to, now what should our order of our ratio be now for the other two sides? Well, AD is longer than DC. We can see that in the picture. So since AD is the longer piece, we're going to put the longer side first, and then the shorter side in the denominator. So we know AD is equal to 11. We don't know DC, it's X. AB is 16, BC is 8. So if we cross multiply, we get 88 equals 16x. And then 88 divided by 16 gives us x equals 5.5 meters. So that is how you can apply that conjecture to this problem. So you're going to go ahead and begin working on your homework. If you have any questions, message me on Remind or through email. And if you have other questions that you want to ask, please ask them at the beginning of class.